Today, I'm pleased to introduce today's session, Building LLM Applications with LangChain, and our guest speaker, Lance Martin. Lance is a software engineer at LangChain with a background in applied machine learning. Prior to LangChain, Lance spent over 5 years as a manager and perception lead on perception for self-driving cars, trucks, and delivery bots. Prior to working on self-driving, he received a PhD from Stanford. Lance is also joined by my colleague, Yujin Tang, a developer advocate here at Zillows. Welcome, Lance and Yujin.
All right. Thanks, Emily. I guess I can just get started here. It's great to be here. Eugene and I have chatted for several months about different projects and ideas, and so it's great to finally be here and speak to you guys. Just as an intro, what is LangChain? It's an application development framework that makes it as easy as possible to develop LLM-powered applications. And you can think of it across kind of 3 layers. There's an underlying platform, which currently is called Langsmith, which has tooling for debugging, testing, and monitoring applications. And we'll give a bunch of examples of that in this talk. Then there's also an open source library of building blocks, which has many integrations, Milvus being one of them, different chains, different LLMs, and we'll talk through all of that. And then kind of on the top is use cases, things you actually want to do with it. And we're going to talk through those as well. Maybe as like a bit of kind of context though, there's maybe 2 general ways that pre-trained LLMs can learn things. One is by updating their weights. You can think about weight updates as kind of cramming before a test. In the case of fine tuning, you're packing knowledge in, given instructions. And there's a lot of good evidence that it's actually bad for factual recall. There's some links I provide below, and you can browse them when you see the slides, but it can actually increase hallucinations. But it is good for tasks like extraction, text to SQL, things where you're modifying the context of an input-output pair. On the other hand, you can, of course, feed information to LLM via prompting. This is retrieval augmented generation, retrieval documents, stuffing them into the prompt. Very good for factual recall. So kind of a good summary of this is fine-tuning is for form, not facts, is a nice summary provided by Anyscale in their good blog post on this topic. This is just something to keep in mind, like when thinking about fine-tuning versus retrieval. And a little bit more on retrieval, you can think about, on one hand, you have these pre-trained LLMs that have, effectively a lot of information packed into their weights. On the other hand, you have, search engines, which just retrieve information. And then there's this middle ground of retrieval augmented LLMs or generation, in which you're actually retrieving documents from some source, Milvus being one, and you're packing into the working memory or context of an LLM and having it do a task. And we're going to talk about a lot of tools to enable this today. And we'll also talk about fine-tuning at the end and when you might choose one versus the other. First, building blocks. So document loaders. This is kind of the first step in really any retrieval application. You need to get documents. And we have a lot of integrations, is the short story. You can unstructured data versus structured, proprietary data, your local files, your local texts, or public data, archive papers, Twitter, Wikipedia, and so forth. So this is kind of how you access data and kind of feed it into a system that can be used for retrieval. Now, we also have text splitters, and these are often required because LLMs have limited context window. You can't just stuff in arbitrary numbers of tokens into the prompt of typical LLMs. It varies, we'll talk about that later. But text splitting is commonly used when you take a bunch of text, split them, and then you embed those and store them in vector stores. That's a very common flow for retrieval, and we'll kind of talk about that in the following slides. It's also worth noting that we have a lot of different splitters that have kind of some tricks. So one is context-aware splitting, where when you take your source document, you break it into chunks, but every chunk retains some tag about where it came from in the original. Like if you're working with code, every kind of code chunk has an attribute that is the function or class it came from. In a markdown file, it'll retain like the headers. In a PDF, it'll retain like the section summaries or the section parts. And this is very useful in retrieval and certain applications. If you want to ask questions about certain parts of a document, there's ways you can provide that. And only those parts of a document can be retrieved. And we may talk about that a little bit later. But the key point here is that there's some ways you can do document splitting that retain context from the original document. Now, this is where things get kind of interesting. We have embeddings in vector stores, and this is kind of where Milvus comes in, of course. So there's, of course, loading, splitting, and you're taking every split, you're embedding it, which is basically mapping it to kind of a representation that can be easily searched, and you're storing that. And as you note here, LangChain's integrations with many different embeddings as well as providers. You can see here, for embeddings, of course, hosted embeddings, OpenAI, hosted vector stores, Milvus, for example. You can also do private. So you can do on-device embeddings with Nomic, on-device with Chroma, for example, on the vector store side. So we have flexibility in terms of how you want to operate. Some people want private, only on device, and we have support for that. Alternatively, hosted has a lot of benefits like scaling, speed, and so there's, of course, integrations there too. Now, LLMs is kind of where, in this retrieval augmented generation flow, it's really kind of the knowledge center, knowledge core of the application. And we have many integrations for LLMs. And the current landscape kind of looks like this. Current state of the art is GPT-4. Context window goes up to 32K tokens, and you can see the cost there. Notably, Anthropic's Claude 2 is quite close to GPT-4. It is cheaper per token. I provide a link there. You can have a look at that. So it's kind of interesting to note. It has a larger context window of 100K tokens, which is quite large. That's around 75 pages of PDF. In addition, there's some open source models that have become very popular recently, Llama2 being one. Cost is free, which is great. The 70 billion variant is about on par with GPT 3.5 for everything except coding. I show that below. You can see, if you look at this final column, Llama2, the coding score is 29.9 versus 48.1 for GPT 3.5. That has some interesting implications, maybe for agents and other things. But the other point of this is, for language, Llama2 is actually about as good as GPT 3.5 for the 70 billion parameter variant. So that's really cool. You can have a free to use. That one's actually a bit harder on your laptop, but in principle, you could if you had enough memory. It is possible to have a free to use open source, roughly GPT 3.5 level model that is yours. That is completely private. So that's pretty cool. It's kind of worth noting what's happened in the open source ecosystem over the last year. I mean, only a year ago, we had models like OPT, which you can see kind of on the left here, which lagged the state of the art by a lot. And in 1 year, we've gotten Llama2, which is what we just said, pretty close to GPT 3.5. One big difference here you can see is base model. So training tokens, we've ramped from like 200 billion to 2 trillion. That's one very important point. The other is fine tuning, and we'll talk about this later. But we've actually found there's a lot of tricks that we're going to cover. Instruction tuned base LLMs can get quite good and rival at least the visible performance of a very high quality, generalist model like ChatGPT or GPT 3.5. And we'll talk about that a little bit. There's some nuances there in terms of, is it actually as good, or is it just kind of, because often they're actually fine-tuned. You can see the instruction counts. They've often been fine-tuned on ChatGPT dialogues. And so there are some questions about whether or not it truly is at that level of quality, but at least it kind of mimics the chat behavior quite well. And there's a lot of activity now on fine-tuning Llama2, of course. So that's kind of the landscape of open source models. This is a fun example. This is Llama2 running on my MacBook. I have an M2 Max, 32 gigs. So it is a better MacBook, but you can see, I mean, this will run at 50 tokens per second. This is close to real time. It's pretty awesome. And this is completely private and free. We have an integrations hub. You can browse all the integrations. I don't want to spend too much time on that. Save time for questions at the end. But let's talk about use cases for a little bit. So we talked about RAG, Retrieval Augmented Generation. This is one of the classic use cases. You start with documents, you split them, you embed and store them, and then you retrieve them. So what's happening here is you take a question, you embed the question, you have all your splits in your vector store that are also embedded. You can do a similarity search across embeddings, cosine similarity. There's lots of ways to do very, very fast embedding lookup. And you retrieve relevant splits related to your question, Like we talked about before, you pack those into the LLM prompt, you get your answer. That's kind of a nice flow that works quite well. We have a few different levels of abstraction. You can choose more or less. This is something that's come up with LangChain quite a bit, too abstracted. I get those concerns. I think the key point is that there's different parts of the library you can use. If you want more control, something like LoQA allows you to completely independently manage the other pieces. If you want an end-to-end kind of pipeline, we also have something that will just kind of do everything for you. So it depends on your level, your interest, and so forth. But the point is we support many layers of abstraction. Now, this is where I'm going to introduce Langsmith a little bit. And so what's happening here is Langsmith is a tool for kind of observability debugging, like we said before. And what you can see here is on the left, when you run one of these pipelines, Langsmith will show you and automatically log the trace of everything that actually happened under the hood. So this is kind of nice. If you want to see like what is actually going on, you can look at the Langsmith trace. And look, you can go down here to the chat OpenAI calls. This is running GPT-3.5. And you can see exactly what's going in. This is kind of cool. So this is the prompt. And you can see all you're doing is use the following pieces of context to answer the user's question. If you don't know the answer, just say you don't know. And then here's literally the chunks that we retrieved from our vector store. This could be Milvus. And you can see that is run here in the trace. I don't know if you can see my mouse, but I'm looking over at the trace. The retriever is run. The stuff documents chain takes the retrieved docs, stuffs them into the prompt. And you can see here, here's the docs, here's the question, and the LLM produces the response based on the docs. So you can very easily audit what is actually getting retrieved, what's going on with tools like Langsmith. So that's kind of what I want to highlight here. Now, chat is kind of a variant of what we just talked about with memory. You can also have retrieval plus chat. So, many retrieval augmented generation applications also enable chat. That just keeps a kind of persistence of your conversation history. So you can see it here. Here's a chat history that's persisted. It's all passed in the prompt. The LLM has that whole history. It can disambiguate like the sentence. It knows it to reference, I guess, where's the sentence? Yeah, this sentence. I love programming. So that's the benefit of chatting. That's pretty intuitive. Now, summarization is another area that we've done quite a bit of work in. And this is a common application. If you start with, for example, a large corpus of documents, you may want to summarize them. And there's a lot of ways to do that. In short, if it fits in the context window, just stuff it in. And with 100K context window models, that's 75 pages of PDF. That's pretty good. But if it doesn't, there's a few tricks. So one is you can take the doc, split it, embed it, cluster it. So you're clustering similar embeddings together and sample those clusters and pass those sample clusters into an LLM. And maybe that will reduce the size significantly while still preserving the essential chunks or clusters that you want to summarize. You can summarize each cluster. You can also do what we call MapReduce. You split the documents, you summarize each chunk, and then you summarize the summaries, basically. And I'll show you a use case here. So we get a lot of user questions in LangChain in our documents, and they're captured by a service called Mendable. So we took 30,000 user questions, and we pushed it through the summarization pipeline using MapReduce, as well as clustering with a few different LLMs. And you can see, here's what we saw with MapReduce. We asked kind of, what are the main themes in the questions? What are people most confused about? And you can see we used MapReduce plus OpenAI. We use Anthropic and MapReduce, and we used OpenAI and clustering. And there's reasonable agreement, which is good. But then this gives us a very nice way to look at this massive corpus of data you can never kind of grapple with independently, using an LLM to kind of synthesize what's going on. We also have the LLM produce example questions in each category. Like give us the top 5 questions, it'll do that. So summarization is very useful for these cases where you have, obviously summarizing large corpus of documents, summarizing massive PDF, things like this, user questions, support tickets. It could be very helpful for those types of applications. Extraction is another major use case. So if anyone has spent time trying to prompt an LLM to give you a JSON output, they know the pain of extraction. It is not easy. So function calling has emerged over the last few months is really a nice way to do this. OpenAI supports function calling. Claude does, Anthropic's Claude does. The open source models are emerging as well. But here's a good example. Given an input sentence and a schema, you can do this function call, which is information extraction function, which will extract information per the schema, and you get what you want out. Now let's look at Langsmith again, and you can see what's happening is right here. This is the output from the function call, and here's the prompt. It basically extract and save the relevant entities in the passage. Use this function, and here's the passage. And so this actually tells the LLM, which is enabled for function calling, to actually use that function, which is then supplied to the LLM as an independent argument. So it's a nice trick. You can specify these functions, pass them to the LLM that supports function calling. In the prompt, the model will then know to use that function if instructed appropriately. And you can see you can get very consistent, high quality output following JSON format, pedantic data class. It's quite flexible. This is another application area people really like. I'm not sure about you guys. I've been a software engineer for a while. I definitely am not very good at SQL. I don't like writing SQL. And there's a lot of nice capabilities now where you can actually have LLMs write SQL for you from natural language. So going from question or text to SQL is a very kind of common and popular application. And we also have chains and agents that can automate both running the query as well as running many queries in the case of an agent. We'll talk about that a little later. But this is actually kind of fun to see. There's some interesting papers on this topic that I link below. But folks have found that you can get quite good performance on text to SQL if in the prompt you give the LLM basically here is what the table has, and here's some example select statements of like what the rows look like. If you give it that, and then your question, it can convert that to SQL pretty effectively. The paper talks about this, it's pretty interesting, but this is exactly what we're doing. So you basically pass the LLM your table, and then what happens behind the scenes is basically LangChain will do this extraction and then pass that information to the prompt LLM. So LLM, when it's doing the SQL generation, has access to your table definition and selection of a few rows. And from that, it's able to produce a SQL query. Now, agents, this will kind of be the last big theme I'll talk about here. This is a topic that's been, of very high interest for a number of months. There's maybe a simple way to think about agents. A basic LLM does not have tools and does not have memory. You can give an LLM access to tools. You can give an LLM access to like an API. We actually have a number of chains that do that. Like you can give an LLM access to a search function, for example. And that's just giving access to tools. So that's like the tools piece. You can also give an LLM memory. So that's like chat, right? We talked about that. If an LLM has some like short-term memory, then you have a chat bot. Chat or memory and tools are agents. That's maybe a simple way to think about it. It's combining these two principles. And there's a few different kind of pieces of this ecosystem. So LangChain has lots of integrations to support agents. On the tools side, there's lots of different tools and toolkits, Google search, Gmail, pandas, many other things you might want to do. For memory, we of course have the vector stores, Milvus being one potential like longer term memory option. There's shorter term memories used for chat like buffers. And then there's a bunch of different types of agents. We'll talk about action agents today. There's a lot of interesting work on simulation. The generative agents paper is very interesting here, where you can actually have agents kind of take on personalities and act as NPCs effectively in a game environment. And there's autonomous agents that are more like long-term planning horizons. That's like AutoGPT, Baby AGI. And we have many different LLM integrations to support the reasoning behavior necessary for agents. Let's talk about action agents briefly. So React was kind of one of the first and most popular action agents to emerge. And you can think about it this way, kind of simply. An LLM with standard prompting does not necessarily exhibit multi-step reasoning. With chain of thought prompting, there's a lot of interesting blogs and works on this. LLMs can do multi-step reasoning. And that's kind of this, you're conditioning the LLM to show its work. Often this is the please think step by step kind of like tag you can include in your prompt. That's chain of thought prompting. It's just conditioning the LLM to show its work. There's a lot of empirical evidence this improves performance on certain tasks. Now, alternatively, there's been a lot of work on getting agents to learn through action observation, through tool use. So this is some interesting work out of Google, the SACAN paper, that basically equips an LLM with like a robotic tools. It can interact with the environment, get observations back, but it doesn't necessarily do multi-step reasoning. And so React was this idea to bring the two things together, give an agent access to tools and allow it to do multi-step reasoning. And let's show a specific example, because this is kind of like high level without an example. So this is actually the SQL React agent that we showed previously. And if you look at the trace here on the left, you can see things that it's doing. So it used a tool to get the SQL database tables. So SQL DB list tables gives it a list of the tables. You can see that's past the prompt here, where you can see the observation from that action is the list of all the tables in the SQL DB here. You can see up here action. I don't know if you can see my marker, but basically the tool/action arrow points to here's the action I performed. Here's the observation from that action. So the action is SQL DB list tables. Observation is here's my tables. And then thought is the next step in the sequence. The thought is I should query the schema of the invoice and customer tables. It defines a new action. And then the action input is invoice and customer. That gets passed down to SQL DB schema. So the original question we actually can't see here. Oh, sorry, we can see input here. List the total sales per country, which country's customers spent the most. And so it's working through this. And you can see it's basically using tools to form actions. Those tools return observations, and then it's thinking about what to do next. That's exactly how these agents work. So hopefully this gives you some like kind of hands-on appreciation for what's actually happening under the hood. I will make a note that if anyone has worked with agents, they've probably experienced this as well. They're not the most reliable. And we actually had kind of a use case for an agent. We wanted to do kind of web research, where you can ask an agent a question. It can go off, scour the web, pull relevant documents, summarize them for you in a nice report. There's some interesting open source work on this. GPT researchers, for one example. We took this up, and actually we found that a retriever was good enough for this particular use case. It was much more reliable than an agent. So I think it's just a cautionary note that you don't always need an agent. In this case, the retriever is able to perform search, basically read or scrape HTML pages, transform them, store them in a vector store. This could be Milvus, for example, retrieve chunks relative to your question, summarize them, and that's all that's going on. We actually have a hosted app that does this. Here's an example, Interweb Explorer. It's all open source. The link is down here. You can see here's here's the answer getting generated to your question from a web search. It gives you all the pages that it scoured to get those sources and everything. So the point is we start with an agent, we end up with a retriever, and we found that, you know, in some cases, retrievers can actually be more reliable. It's kind of all you need for this particular application. Now, in the final section, I want to save a lot of time for questions, so I'll make this a little bit quick. We'll talk about tooling and Langsmith in particular. We've seen a lot of Langsmith traces. But again, I'll emphasize this point about fine-tuning versus prompting or retrieval. And I'll show you how we use Langsmith to perform a case study on fine-tuning. Now, as a note, we talked about fine-tuning is really good for things like tasks, form, extraction. It's less good for things like retrieval or factual recall, in which case retrieval augmented generation is typically much better. Again, I linked the sources below. So we focused on an extraction task. And the task is kind of esoteric, but it's extraction of knowledge graph triples. So if you ever built knowledge graphs, you typically build these, it's built from these triples of subject, predicate, object. And we wanted to see, hey, how well can LLMs kind of do this extraction? We actually have a playground here. It's an app, open source, free to use. And you can pass in any text. and it'll perform this triple extraction. You can see the triples down here. So we actually collected a lot of examples of this. We released this a couple weeks ago. Lots of people played with it, input different text inputs to the app. And you can see this feedback button down here. Now, this is where kind of Langsmith comes in. This is connected to a Langsmith project, and Langsmith collects all those outputs. Imagine that being all your user outputs or all your LLM generations in your app that users are interacting with. Imagine users can give feedback up, down. You can take that in Langsmith and filter on bad feedback and say, okay, here's all the places that the LLM's doing bad. And let me try to fine tune the LLM to improve on that. So this is kind of an example case. You can collect those generations at relatively large scale within Langsmith. You can do this querying for what if you want to query all the bad generations. You can build data sets, and you can expect them and clean them all within Langsmith. And that's kind of what I'm showing over here. Now for the fine-tuning piece, you can effectively take your data set, split it into a train and test set, test for evaluation, which also Langsmith enables, train set. You can build more synthetic data if you want. We don't talk about that too much here, but that's another interesting option. And then you can fine tune. So this is kind of the flow. Langsmith lets you, if you have an application running, easily collect all those generations, filter them according to various things you care about. Could be time, could be user feedback, build data sets from them, inspect and clean those data sets. And then those are set for different things you want to do. One being evaluation, another being fine tuning. So in our case, here's an example. We took this triple extraction challenge and we tried a few different things. We first tried few shot prompting, GPT-4, and GPT-3.5. We tried base Llama2 7B, and we tried fine-tuned Llama, fine-tuned GPT-3.5, which actually just came out 2 or 3 days ago, the ability to fine-tune ChatGPT. It's very interesting. We evaluate all of them with Langsmith. Langsmith gives us this metric from 0 to 100 on performance. And what's kind of cool is it gives us a very nice way to audit all of those evals. This is kind of what you can see here. You can drill in, and every generation you can see here's the score for that particular generation, and you can dig in even further, which I'll show shortly. And I'll talk about conclusions here, but this gives you kind of stack rank. We actually found few shot GPT to be the best, fine-tuned GPT-3.5 to be second, fine-tuned Llama2 to be third, few shot GPT-3.5 to be fourth, Llama2 base fifth. It actually kind of matches what you might expect. We'll talk about this in a little bit more detail. First, I kind of want to show you what's happening in fine-tuning. So this is kind of funny. I don't know if you can see it, but this is the base Llama2 chat. The answers we want, you can see, are like these very specific extracted clusters. They're almost like JSON, basically, where you want subject-object relation, right? Subject-object relation. The baseline model doesn't know that. It answers in this informal way. The question here is, by this point, Simpson had returned to his mansion in Brentwood and surrendered to police. This is probably about O.J. Simpson. The model hallucinates Homer Simpson as a subject. And it says subject is Homer Simpson, object is police, relation surrenders. It kind of does this hallucination. You can see the output is this like chatty style. It's not what we want. With a trivial amount of fine tuning, you can see we can get much closer. Now, it's still not perfect, and we can talk about that, but it's much closer to the output style we want. This is only on fine tuning on like 1,000 instructions. On an A100 in Colab, this takes only about 5 minutes. It's very quick. You can see you can get much closer to the intended output. So maybe just to summarize, we can then move to questions. Langsmith can help address some pain points in the fine-tuning workflow, data collection, evaluation, inspection results, like we said. We found that RAG or few-shot prompting definitely should always be considered first before you undertake fine-tuning. Few-shot prompting of GPT-4 actually was the best performer, but fine-tuning small open source models cannot perform much larger generalists. Fine-tuned Llama chat is actually better than GPT-3.5. So that kind of matches what's been reported elsewhere in the literature and recent blog posts. And that maybe gives you a flavor for how Langsmith can work in a practical application like fine-tuning. And with that, I think I'll just open it up, leave questions. I think we're only at half hour, so plenty of time. maybe I'll just stop talking and open the field up if there's any questions or topics we want to discuss more.
Great. Yeah. Thanks for this really good overview of all of the things that are kind of going on with this LLM app building stuff in LangChain. I have quite a few questions. I will let people ask questions in the chat before I kind of start rattling off questions. But if we don't get any questions like being typed up in the next minute or so, I'm going to start asking away.
Yep.
Okay, I don't see any pop up yet. So I think that there are some parts of this presentation that I would have loved to dig in deeper on.
Yeah.
And so one of the things I wanted to ask about was, why is it that these agents are not like super reliable? Can you talk a little bit more about like how come sometimes the agents will give you different steps, or perhaps even not be able to run the steps they like? Sometimes like they'll repeat their steps and then it's like, okay, this is not very useful. Can you talk a little bit more about that?
Yeah. So one thing I'll note is empirically we've seen, trying to find the agent part. Empirically, one thing we've seen is that agents with, for example, the open source Llama models are notably worse than agents with some of the hosted closed source proprietary models. One hypothesis I've heard for this is that they're quite a bit worse, and I'll go back to where I show the data. They're quite a bit worse at coding, and there's some speculation that coding ability or that kind of the structured reasoning present in coding is something that is quite important for agent behavior. That's maybe one thread. The second thread, and frankly, I am not an expert in agents. I actually haven't done that much work with agents. So I would defer this to folks that have deeper expertise in this area. But frankly, I found that in my work with agents, the difficulty in actually inspecting what they're doing under the hood is one of the main challenges. And that's actually one of the main motivations for using Langsmith. Like here, you can actually see its trace and progression to actually understand if it gets stuck, where it gets stuck, and why. That doesn't necessarily answer the why question, but it does help you understand where precisely things are going haywire, which I found to be a missing piece when I've worked with agents.
Sure.
So I think one is logical reasoning in the form of coding is certainly one empirical place that we've seen is very important for agents. Two is the ability to actually trace. It could be like implementation problems. It could be actually like LLMs getting confused. And frankly, I found it very helpful to be able to inspect the prompts specifically going into the agents using something like Langsmith. I've actually done this a decent amount with generative agents, the more recent simulation agents. And it's been very helpful to see what's actually going in the prompt to help debug why and where it's getting confused. I think it's very nuanced as to where and why agents go off track. I think just good observability is like the starting point. That's maybe what I'll say for now.
Cool. Yeah, so now we have a few questions that have popped into the QA. So do you want to talk about automatic evaluation of prompts?
Let's see. Of prompts in particular. Well, so
maybe eval in general, because I actually wanted to ask about eval in general as well. So I think this would be a great chance to kind of talk about both.
Eval is a good topic. So I actually put out an open source eval app called Auto Evaluator a couple months ago. And the main intuition there was you can have LLMs themselves grade responses. So if given a generation and an output statement, an LLM can look at those and reason about whether or not it's accurate or not. Now, this is kind of a big topic. There's actually a few pretty good OpenAI cookbooks on this. We had a seminar on it a while. The OpenAI folks basically contended that LLMs can perform discrimination pretty effectively. So if given like a sentence, a generation, and like a ground truth sentence, it can compare those pretty effectively and say, these are factually consistent.
Okay.
So that's kind of the central idea behind a lot of the evals that we're doing here is like an LLM-based grader, typically GPT-4. So what's happening here is, for example, for these applications, remember, this is outputting these triples. So you can kind of see here's like some examples. Here, let's look at this explicitly. So here's like the LLM's output. It's this basically this structured list and has subject-object relation, and we have our reference output. And an LLM is going to look at these two output generations and make an assessment as to how consistent they are. And there's a lot of questions there. And in fact, you should check out our, we open source the Colabs as well. You can actually see the grading prompt that we use. And you can certainly tune that. I think there's a lot of questions about LLM mediated evaluation and grading, but at least you can see exactly what we're doing. And the point is we're using LLM grader with a very specific grading prompt. And it is assessing the consistency between the LLM output and the reference. Now, prompting plays in there because, of course, you can tune your prompt, produce different generations. In fact, we did quite a bit of that. And you can do a grading across those generations and determine the best quality prompt. That's something we actually did quite a bit of. So is that enough of on eval, or do you want to go a little deeper?
I think that's a really good coverage of eval. Like, I have heard some other people talk quite a bit about these kinds of like using LLMs to evaluate other LLM outputs. And it looks like the person who asked the question is also pretty satisfied with that response. So the next question is about use of data labeling tools for scoring and judging outputs. Any thoughts and comments?
Okay, so that's a great topic. The hardest part, I mean, folks who have done ML kind of appreciate this. The hardest part of any ML project is the data acquisition. That's always the hardest part. And what's very interesting, actually, is we have these notebooks below. Fine-tuning your LLM is pretty trivial. You can do it on a single A100 or even a T4 GPU in 15 minutes, depending on your instructions. I mean, on an A100, I was able to fine-tune with 1,500 instructions in like less than 5 minutes for this task.
Okay.
The fine-tuning part's trivial. It's the data and the evaluation that's annoying and hard. I mean, look, getting high-quality ground truth is always of paramount importance. For this, we used public data actually in the end. So there's open source triple data sets that we used to keep things simple, in part because we found, we kind of go here, getting an LM to produce triples is not good enough, basically. And this is where data labeling could have come, if we really cared, and this wasn't just a demo, we would have probably gotten some, and there's a lot of labeling. So I've done a lot of work with scale in the past. We probably would have gotten, human annotation to supplement synthetic data. There may be two different threads here. One is getting high quality human annotations is certainly a great idea for any project. Synthetic labels is a very interesting topic area. We could dig into that wormhole if you want. I've seen variable results. It can work very well. In this case, we tried. It was actually quite hard to get it to match the exact output format of our true labels. So there's some nuances with synthetic, but I think it is the case that always consider how you're going to get high quality annotations, and human labeling is a great option. Scale, I know, obviously has a lot of services, and frankly, I've worked with them in the past. They're very good. It's always the hardest part, especially when it comes to building a high quality eval set.
Yeah, I mean, I've worked in NML and I totally agree. I mean, people ask me about this and I'm like, yeah, the most important thing is you got to have good quality data, right? So the next question is someone's using LLMs for splitting, but they want to know, they say that they're letting the LLM model split the text and create semantic boundaries, I believe is what this word is. What are your thoughts on using an LLM model to do your splitting or chunking?
That's interesting. I haven't come across that. I'd be curious to know why. I can see the intuition maybe, like you want to group similar text together. Now, there's a lot of ways to do this. So first, I'll make a note. We actually have, and I'll share it's actually linked here, but we actually have a splitter that does kind of intelligent splitting for code, where it will keep classes or functions together in the splitting process itself. So that's kind of one example that's getting at what you're saying. Another is this context-aware splitting will retain the metadata. So even if you split, for example, this PDF, imagine you have a long abstract, you split that into 3 chunks, those chunks still have the abstract tag with them. So you can always metadata filter for them in retrieval, so you can recover them. So actually, I think this approach probably makes more sense than having an LLM split. But I would be open to hearing more of the rationale for why you'd want an LLM to split. I think if you can get very high quality metadata, basically attribution to your chunks with like one of these types of tools, then you can always recover them with metadata filtering.
Yeah.
So.
I agree. Mason, if you want to drop a little more of your comments on why you guys are doing this in the chat, that would be awesome to see. I personally agree with this as well from like a, kind of both a cost optimization and also a kind of like architecture / structure kind of angle. Our next question is, could you share more about what task and amount of data was used for the fine-tuning of GPT 3.5 / Llama2 versus two-shot, and which type of fine-tuning it was? Was it prompt tuning or other parameter efficient fine-tuning, or an end-to-end one?
Yeah, exactly. So this is actually where I'll share these slides. You can see the blog post and the collabs are all there. But in short, so here's the task. The task is triple extraction. So you're given a chunk of text and you're extracting knowledge graph triples from it. So that's the task definition. Now, there's a few open source data sets for this of variable quality. We ended up using 2, Carb and Benchy. And it basically was 1,500 examples of sentence alpha triple pairs in our train set and 100 in our test set. Now, in terms of fine tuning, so we use Llama2 7B chat model. We do this in Colab on a single A100 GPU. We use parameter efficient fine tuning with QLoRa. So that means the model weights are all 4-bit, which is great. You can fit it right in memory, especially with an A100. Even on a T4, that'll work.
Right.
And you're actually only saving the weights for a small fraction, roughly 1%, I believe, of the weights of basically the QLoRa adapters that are basically injected into the model itself. So those are the only things you're actually saving. All the computations done in FP16, and those QLoRa weights are also saved on FP16. You rebuild the model at the end, you save that all FP16, and that's what you run inference and evaluations on. That's really all that's going on. So again, you have a 7 billion chat model, Llama2 chat model. You're using 4-bit quantization to load it into memory. Then the memory footprint is on the order of like less than 10 gigs. That's great. Fits easily in GPU, VRAM. You're doing parameter efficient fine tuning. You're fine tuning a small fraction of the parameters, maybe roughly 1%, saving those, FP16, rebuild the full model FP16, save that. That's all that's going on. It's fast. It's not that expensive. It definitely improved performance. If you want to do better, there's a ton of ideas to make it better. This was just a quick demo, but it's cool. This stuff works in Colab. It's very accessible. You don't need that many examples. I think it's really about example quality. Now, I did all that work. A colleague of mine did the OpenAI thing, and that just came out 2 days ago. He used a smaller number of instructions for that particular one. I think it was only like 500 or something. I should go back and that literally got added yesterday at the very last minute, so I didn't go through that work very carefully. We have a separate notebook for that though as well, and it's quite out of the box. So in that case, I don't think you need to worry about any of the parameter efficient stuff. I think, as far as I understand, we can look at the notebook together right now if we want. But I think you just send that data over to OpenAI. I'm sure they do the fine tuning on their end, and then you just presumably get a hash of a model checkpoint back or something. I think that's even easier. So in short, Llama fine tuning collab works really well. I mean, with an A100, you can also do a 13 billion parameter model. And it seems like the GPT 3.5 fine tuning, I mean, my colleague turned that around in like an hour. So I think that's quite trivial.
Wow.
Yeah, so these are both really good options to consider. But again, I would highlight our conclusions. Always look at simpler methods first. Always look at RAG first. Look at few shot prompting. Like they'll often get you what you need. When you really need to fine tune, don't fine tune for factual retrieval. Fine tune more for form, things like extraction of triples or summarization or like a particular style of speaking, like kind of style transfer. Those are all good fine tuning tasks. But yeah, happy to talk about them more. It's a great topic.
Yeah. Thanks. That was a very like, comprehensive answer for that. Okay, what about policy enforcement of guardrails on LLMs? Do you have any thoughts or comments
Yeah,
about?
that's a good topic area. I mean, I know Shreya's guardrails library is popular. I think it's interesting to consider. I have not worked with it personally much at all, but it seems compelling. The one thing I'll note is on the topic of hallucinations, if you go back to the retrieval augmented generation piece, you know, when you structure these prompts, you tell LLM, right, use the following pieces of context to answer the question. If you know the answer, just say you don't know. Don't try to make something up. My experience is this is pretty good at managing hallucinations. I certainly would not argue that it's foolproof. I think it may be wise to consider guardrails on top of this. I think, frankly, building an evaluation set using Langsmith or otherwise, or running evaluations carefully in your application to understand where it goes out of bounds is probably the thing I would do first. And then I think about, okay, if that can't be addressed with prompting, then maybe I want some additional guardrails on top of my application. That's probably what I would say about it. But my sense is that with RAG, you actually are already prompting the model to limit hallucinations quite a bit. Evaluation may tell you where it's leaking out, and then you may address that accordingly, maybe with guardrails.
Yeah, yeah. I mean, with RAG, what we typically do is we're setting the temperature to 0 on the LLM, and we're basically only using it to structure the results into a human readable context.
That's right.
Yeah. Okay, so someone asks, is there a node code functionality, or will I need to code everything? Is there? I'm asking. I bet this is actually asking if there's a no code functionality, or if there's no code functionality. Basically, that's what it seems to be asking.
Okay, for LangChain in general. I've actually seen some open source projects that do provide that, but I can't think of them specifically right now. I would hunt around. I'm not sure that's very mature, to be honest with you. But the thing I will say is there's low code. Like, for example, if you want to do RAG, we do have some options. You can see the documentation. If you want to do this in 2 or 3 lines, you can use this. Frankly, LangChain gets hit a lot or critiqued a lot for being too abstracted, which I completely understand. And that's why I present, look, there's many different ways to do things in LangChain. And frankly, if you want to be as close to the metal as possible, so to speak, you can use very, very lightweight like LLM chain only, and then customize everything yourself. Only use LangChain for like logging the generations and Langsmith or something. I completely appreciate that. Frankly, in production, I might advocate something like that. But we do have abstractions that would allow you to do certain things like RAG in like 2 or 3 lines of code. So low code, not quite no code, but yeah, I would look around. We don't offer anything ourselves. The Langsmith stuff is pretty low / no code. With Langsmith, you literally set an environment variable and everything gets logged to your Langsmith project, and you can browse and like it's all UI based. So Langsmith is actually pretty low code, which is nice. All this stuff, tracing and so forth, you get for free. Just set an environment variable in your project. It all gets logged to Langsmith. You can open up any trace and play around. And so it's quite nice.
Okay. Yeah. Looks like. Oh no. It's Yeah, so I think we've got time for maybe one more question. And it doesn't look like there's any questions in the QA. So, oh, someone asks. Someone wants to ask about your thoughts on using Langflow or Flowwise. Have you heard of these tools?
Yeah. I think those may be some of the lower no code options that are, in short, I haven't played with them at all. Yeah, tell me what they are maybe, and then I can respond. Might
I
be.
I don't know what they are. I've never heard of these tools. So that's why I was like, so this question to me is a little bit confusing.
Okay. I've heard the names. I've not personally played with them. Yeah, if the questioner wants to provide more context, I'm actually happy to comment on it. I'll look it up right now. Langflow.
I
UI
think
LangChain. Okay, yeah. Yeah, it looks like it's quite popular actually. Langflow UI for LangChain.
yeah, that's what he
Looks
said.
kind of cool. Effortless way to experiment prototype LangChain pipelines. It's like kind of drag and drop functionality. Looks like a lot of adoption on GitHub. It looks interesting for sure. I haven't played with it personally, but I think it seems like a nice option depending on your needs, aptitude for coding, and so forth. But it looks pretty cool, actually.
Yeah. Okay, then I think we're probably out of time for any more questions. Emily, do you want to kind of take over, wrap things up?
Sure. I just want to thank everyone who spent some time with us today for this session, and special thanks to Lance from the LangChain team for sharing so much great information and walking us through all of these different concepts. Eugen, thank you as always for co-hosting, and we hope to see everyone on a future Zillow's webinar. Have a good one.
All right, thanks.
All right. Bye.